Hi there, my name is Tawfiq Omar, math teacher. In our lesson for today, we will talk about Chapter 4, Lesson 1, Application of Differentiation, First Derivative Test. Part A, Critical Point and Increasing and Decreasing of the function. Definition of critical value. F is a function, x equal to c is a critical value if fc is defined. The function at x equal to c must be defined. F prime of c is equal to 0 or f prime of c is undefined. That means we have two conditions. One of them, f of c is defined and f prime c must be 0 or undefined. Steps to find critical value. The first one, find the domain of the function. The second step, find the first derivative. The third steps, find values of h when f prime of x is equal to 0. Fourth step, find values of x when f prime of x undefined. Step number 5, if the value of x in domain, which mean the value which we find it at step 3 and 4, if they are in the domain of the function, then they are a critical point. Example, the critical value for the function fx equal 2 times x squared minus 9 over x squared minus 4 is. First of all, we must find the domain. To find the domain, make denominator equal to 0. X squared minus 4 is equal to 0. If we solve this equation, then x is plus or minus 2. That means domain is all real number except minus 2 and 2. Take the derivative. The first derivative, f prime of x, is denominator x squared minus 4 times the derivative of numerator, which is 2 times 2 is 4, x, minus numerator 2x squared minus 18 times the derivative of denominator, which is 2x, over denominator square. Opening the brackets, then it be 4x times x squared is 4x cubed minus 4x times 4 is 16x minus time positive is minus 2x times 2x squared is 4x cubed minus time minus is plus 2x times 18 is 36x over x squared minus 4 squared. Cancelling 4x cubed with 4x cubed and minus 16x plus 36x is 20x. And now to find in which value of x the derivative of the first derivative is 0. Then make f prime of x is equal to 0, which means 20x over x squared minus 4 all square is equal to 0. That means 20x is 0. That means x is 0. Because 0 is at the domain, it is a critical value. And now to find the value of x when the derivative is undefined. To find this, make the denominator of the derivative equal to 0. Then find the value of x. X is equal plus or minus 2. As you can see that these two value is not belong to the denominator, therefore they are not a critical value. That means we have only one critical value, which is x equal to 0. Example, the critical value for the function fx equal 1 minus sine x over cosine x at the interval 0 to 2 pi is. First of all, to find the domain, make cosine equal to 0. Cosine it be 0 at the 19 and 270, or pi over 2 and 3 pi over 2. Therefore, we make the domain is equal the interval from 0 to 2 pi except pi over 2, 3 pi over 2. And now take the first derivative. The first derivative is the denominator times the derivative of numerator minus cosine x minus, and now the numerator 1 minus sine x times the derivative of denominator, which is minus sine x over denominator squared. Simplifying, it becomes f prime of x equal minus, by taking between these two terms minus 1 as a common factor, it becomes cosine square plus sine square x plus sine x. As we know that cosine square and plus sine square is 1, therefore f prime of x is equal minus 1 in place of cosine square sine square is 1, then minus 1 plus sine x equal to 0. Therefore, minus 1 plus sine x equal 0. Then sine x is equal 1. Sine it be 1 at the 90 degree. Therefore, x is equal pi over 2. But it is not belong to the domain of this function. Therefore, it is not a critical point. And now, to find the value of x when the derivative is undefined, make the cosine of the derivative, the denominator of the derivative, equal to 0. Then x equal pi over 2, x equal 3 pi over 2. Both of them is not belong to the domain, therefore they are not a critical point. That means this function has no critical point at the interval 0 to pi. Example, critical value for the function fx equal x minus 1 square x minus 3 is, first of all, domain of this function is all real number. And now find the first derivative. The first derivative is the function is the product of two functions. Therefore, we use the product rule, which means the first one, x minus 1 square, times the derivative of the second one. Time of derivative of x minus 3 is 1, plus the second one, x minus 3, times the derivative of x minus 1 square. Write 2 down and then write x minus 1 as same. Then the power minus 1 is 1. Then time the derivative of inside the bracket, which is 1. And simplifying by taking x minus 1 as a common factor, it becomes x minus 1. Then open a bracket. Here remain x minus 1 plus 2 and x minus 3. Therefore, x minus 1 plus 2 times x is 2x, 2 times minus 3 is minus 6. Then f prime of x is equal x minus 1. X plus 2x is 3x, minus 1 minus 6 is minus 7. And now let the derivative be 0. Therefore, x minus 1, 3x minus 7 is equal to 0. Or x minus 1 is equal to 0, or 3x minus 7 is equal to 0. Here, x become 1, and here x become 7 over 3. Because both of them at the domain of the function, therefore they are a critical point. The critical value for the function fx is equal sine x plus cosine x at interval 0 to pi s. Domain of this function is 0 to pi. And now find the first derivative. The first derivative is equal. The derivative of sine is cosine minus the derivative of cosine is minus sine. And now make the derivative equal to 0. Then cosine minus sine x is equal to 0. Take cosine to the right side, or take minus sine to the right side and write sine x is equal cosine x. Dividing both sides by cosine x, it becomes cosine sine x over cosine x is equal 1. Sine x over cosine x is tangent x is equal 1. Tangent is equal to 1 when belong to the first quarter and x is equal pi over 6. When x belongs to the third quarter, when x is 5 pi over. How we find it the second one? At the third quarter, x is equal pi plus pi over 4. Then 4 times 1 is 4 plus 1 is 5. Therefore, it is 5 pi over 4. And now they are a critical point because they are belong to the domain of the function. That means C is a correct answer. Which of the following is the critical point for the function fx equal x to the power 2 over 3 minus 4? First of all, take the derivative. The derivative is write down 2 over 3, then x, take the from power 1, then simplify it, is become 2 over 3 x. 2 minus 3 is minus 1 over 3, and then 2 over 3 square cube root x. Because the numerator is constant, then this derivative is not equal to 0. And now take the denominator and equal it to 0, then x is equal to 0. As you can see that x belongs to the domain of this function, because domain of this function is all real number, then x equal to 0 is a critical value, as you can see here. Increasing and decreasing of the function. F is increasing for all x if for all x1 and x2 belong to the interval IB and x2 is bigger than x1, then f of x2 is bigger than f x1. Definition: the graph of the function moves upward when x moves on x-axis from the left to the right, and the graph of f prime is over the x-axis. You can see here that is the function is going upward like this, going upward. This means that this function is increasing because we are moving from left to the right. And if you see the red curve here, the red curve here is the curve of the f prime of x, that you can see it is over x-axis. Every time is positive. For all x belong to AB and f prime of x bigger than 0 is a positive. This is the definition of the increasing interval. And now the decreasing interval, as you can see here, f of x is going down, decreasing to the down when we moving from left to the right. Or if for all x1 and x2 belong to the interval AB and x2 is bigger than x1, then f of x2 is less than f of x1. That means when x become bigger and bigger, y it's become smaller and smaller. At the graph you can see that the graph of the function moving downward when we move from left to the right, and the graph of f prime of x, the first derivative, is under x-axis. That means it is a negative for all x from A to the B. As we know, you have increasing and constant and decreasing. F is differentiable function. F increasing if you see that the f prime of x is bigger than 0. That means if the derivative at this interval is positive, AB. Or if you see that the function is increasing, f is increasing at the AB, and the graph of f prime of x over x-axis. The function be constant or be as a line parallel to the x-axis if f prime of x is equal to 0 on interval AB. Or the function be decreasing when f prime of x is less than 0, or its graph is under x-axis at the interval AB. Steps to find the increasing and decreasing interval. Find the critical value. The second, draw the critical value on the number line. These critical lines supplies the number line to parts. If you have one critical point, then the number line be 2 parts. If you have 3 critical point, then the number lines 4 parts. In each part, take a number and replace it instead of x in the f prime of x. That means take a number in each part and replace it in derivative. If f prime of x is bigger than 0, if the derivative is positive, then it is a increasing interval. But if f prime of x is less than 0, then it is a decreasing interval. Example: find the interval on which f of x is equal x cubed minus 3 over 2x squared is increasing or decreasing. Domain of this function is all real number. F of x is equal x cubed minus 3 over 2x squared. The first derivative is 3x squared. 2 times 3 over 2, cancelling 2 with 2, remain x. Then remain 3 and take from the power 1, it become x. That means the first derivative is 3x squared minus 3x. And now make the derivative equal to 0, then 3x squared minus 3x is equal 0. By taking 3x as a common factor, then 3x remain x minus 1. When 3x is equal to 0, then x equal to 0. When x minus 1 equal to 0, then x equal to 1. Because both of them are the domain of the function, therefore they are critical values. And now draw the number line like this. X, you have 2 critical points. Write it from left to right, to the right, small and bigger. Minus infinity to the infinity. You have the first critical point is 0, and the second critical point is 1. And now let us search for the value of f prime of x. At x equal to 0, then f prime of x is 0. At x equal to 1, then f prime of x is 0. And now let us take a number from minus infinity to the 0. Take a nearest point to the 0, which means minus 1, and replace minus 1 as the derivative of function. Then f prime of minus 1 is equal 3 times minus 1 squared minus 3 times minus 1. It becomes 6. It is bigger than 0. That means at this interval from minus infinity to the 0, the first derivative is positive. That means it is increasing. And now between 0 and 1, take a half, 1/2, 0.5, replace it as the derivative. F prime of 0.5 is 3 times 0.5 squared minus 3 times 0.5. It becomes minus 0.75. It is less than 0. That means the value of f prime of x is negative. And now take a number here bigger than 1, let be 2, and replace it at the derivative. It becomes 6 bigger than 0. That means it is positive and increasing. Therefore, increasing interval is start from minus infinity to the 0 and from 1 to the positive infinity. But the decreasing interval is from 0 to the 1. But be careful every time these intervals are open. Another example, find the interval on which f of x is equal 1 over 3 x cubed minus 3 over 2 x squared minus 9 over 2 is increasing or decreasing. Domain is all real number. And now take the derivative. The derivative of 1 over 3x cubed, cancelling 3 with 3, remain x squared, minus cancelling 2 with 2, remain 3x to the power 1. And now make the derivative is equal to 0, then x squared minus 3x is equal to 0. Take x as a common factor, x is times x minus 1. When x is 0, then when x minus 3 is 0, then x is 3. You have two critical points. And now draw the number line. X you have from minus infinity to the positive infinity because the domain is all real number. Then you have the first critical point 0 and the second critical point is 3. And the value of f prime of x at 0 is 0, at 3 is 0. And now take number, let be minus 1, replace it at the f prime of x. F prime of minus 1 is minus 1 squared minus 3 times minus 1 is equal 4 is bigger than 0. That means here is positive and the function f of x is increasing. Take between 0 and 3 a number and replace it. You can say 1 times y minus 3. 1 minus 3 is minus 2. Minus 2 times 1 is minus 2. That means it is minus 2. Less than 0, it is decreasing. And here you have increasing. Increasing interval is from minus infinity to 0, from 3 to the positive infinity, and decreasing interval is 0, 3. Check it out. Find the interval on which fx equal x plus cosine 2x in the interval 0 pi over 2 is increasing or decreasing. The domain of this function as it is given is from 0 to the pi over 2. And now find the first derivative. F prime of x is equal, the derivative of x is 1, minus the derivative of cosine is minus sine 2x multiplying by the derivative of angle, which is 2. Then f prime of x is equal 1 minus 2 sine 2x. Let the derivatives be equal to 0, then 1 minus 2 sine 2x is equal to 0, and then simplifying x sine 2x is equal 1 over 2. Because sine is positive, therefore the 2x is belong to the first quarter or the second quarter, and the basic angle is pi over 6. At the first quarter, 2x is equal pi over 2. By dividing by 2, then x is equal pi over 12. Pi over 12 is 15. It belongs to the domain, therefore it is a critical point. And at the second quarter, 2x is equal pi minus pi over 6, which means 6 times 1 is 6 minus 1 is 5, 5 pi. By dividing by 2, then x is equal 5 pi over 12. 5 times 15 is 75. That means this is belong to the domain. That means it is a critical point. And now draw the number line. X, you have two critical points. Your interval is from 0 to the pi over 2, and you have two critical points. One of them is 15, and the second is 75. And now searching for the sign of the f prime of x. F prime of x is 0 at pi over 12 and is 0 at 5 pi over 12. And now we are searching for a number. This one is 15 and this is 75. Then we must take a number here. Let's take 30. Then replace 30 at the f prime of x. Therefore, f prime of 30 is equal 1 minus 2 times sine 2 times 30. It is 1 minus 2 sine 60. Therefore, it becomes minus 0.73. That means in this interval from pi over 12 to the 5 pi over 12, the sign of f prime is minus. That means it is decreasing. Because here decreasing, here is increasing, and here is increasing too. Therefore, it is positive, increasing, and here is positive, decreasing. That means increasing interval is from pi over 12 to the 5 pi over 12. This is decreasing interval, and increasing interval is from 0 to the pi over 12 union 5 pi over 12 to the pi over 2, and decreasing interval, as we said, from pi over 12 to the 5 pi over 12. In which interval the function f of x is equal x plus sine 2x in the interval 0 pi over 2 is decreasing. Here we must know where is decreasing. Take attention that you have some value for x: 0, pi over 2, 0, pi over 3, pi over 3, pi over 2, pi over 3, 2 pi over 3. As you can see, 2 pi over 3 is 120. That means it not belong to this interval. That means this one is not a solution. And now we want to know, you have some value. First of all, find the first derivative. F prime of x is equal 1 2 cosine 2x. And now draw the number line and put the value of x which you have at the given and at a, b, and c. You have 0 and you have pi over 2 and you have pi over 3. And now to know this interval, take at each interval a number, or pi over 3 is 60, then we must take number or angle between 0 and 60. That means it's 30. And now replace, and here between 60 and 90 take 70. And now replace 30 at the derivative. That means 1 sine of 2 times 30 is 60, which equal 1 plus 2. Cosine of 60 is 1 over 2. Cancelling 2 with 2, then become 1 plus 1 is equal to 2. Because it is bigger than 0, that means here is increasing. And if you, because at 0 to the pi over 3 is increasing, that means it is decreasing at pi over 3 to the pi over 2. Or replace 70 at the derivative, it become 1 plus 2 cosine for 140, which become 1 plus, as you can here use a calculator to find 2 cosine 140, then it become minus 0.5, which is less than 0. That means the function is decreasing at interval pi over 3 to the pi over 2. That means C is a correct answer. Here we reach at the end of the lesson. Thank you for watching, and please share it with your friend to everyone get benefit, and press the like button and write your comment if you have, and subscribe the page. Thank you for watching again. Goodbye.